My name is Kellen. Welcome to the course. In this chapter, we will figure out about a necessary condition for QCA, or we call csQCA. It's time to dive in the logic of necessity for QCA. A condition is necessary for an outcome if whenever the outcome is present, the condition is also present. There should not be a case that shows the outcome, but not the condition. We can derive the expression of necessity as the condition X, the arrow right to left, and the outcome Y. With that statement, we can read if Y, then X, or Y logically implies X, or Y is a subset of X, or X is a subset of Y. Usually, when we are talking about necessity, we are talking about the subset relation. With necessity for QCA, only those cases that are the members of the outcome are relevant. We should focus on cases for which the outcome is present and try to check if for which the condition is also present. We can demonstrate the test of necessity for QCA using a data matrix. For instance, we have one QCA condition X and one QCA outcome Y. The values in these two columns, one indicates the condition or outcome is present, while 0 indicates the condition or outcome is absent. There are 4 cases are logically possible A, B, C, and D. When we have cases with Y equals to 1 and X equals to 1, like case A, and no cases with Y equals to 1 and X equal to 0, like case B, then we have empirical evidence to confirm that X is necessary for Y. In addition, with a necessity claim of X for Y, cases with none Y are not covered, and we are not interested in the value of X in those cases, such as case C and D. We also can demonstrate a claim of necessity by a 2x2 table. Again, only cases with Y present and X present are relevant, while cases with Y present and X absent are avoided to have enough empirical support for the claim that X is necessary for Y. Another useful method to present necessity is Venn diagram. Each circle is a set. We have the outcome set Y and the condition set X. If X is necessary for Y, then the circle for set Y is fully contained in the circle for set X. Or we say X is the subset of Y. The area outside Y but inside X means Y is absent and X is present. And we also have the area outside Y and outside X means both X and Y are absent. These two areas are not relevant to the claim of necessity of X for Y. We also see the rectangle around the circles in the universal set. This diagram does not display any area with cases that display Y but not X, as required by the logic of necessity. Again, only cases that display both X and Y are relevant for the necessity claim. Let's use one example as a case of necessity for QCA. We are interested to examine the conditions for high performance outcome. Theoretically, we expect the three condition sets. A stand for firms investing in AI, D stand for firms investing in data, and B stand for firms investing in people, are necessary for the outcome HB, high performance firms. Each row is the observation from one specific firm, and each column has QCA values. One means a full member of a set, and 0 means a non-full member of the set. The first examination, we may start by asking which individual conditions, A, D, or P, are necessary for the outcome. Let's start with the first condition, A, firms investing in AI. Based on the logic of necessity for QCA, only those cases that contain the presence of the outcome are relevant. We are supposed to find the conditions are also present in all these cases. For condition A, it fails this test when the outcome is present, but the condition is absent in case number 1. This is enough by itself to show that the condition A, investing in AI, is not a necessary condition for high performance firms, regardless of what happens in other cases. Now we can arrive the same conclusion for other conditions, D and B. In the next step, we can ask whether a combination of conditions is necessary for the outcome or not. We have some reasons to expect firms investing in either AI or people may have positive outcome. Then we may add a new column, which is a new condition, A or P, or the union of A and B. This column represents the membership of all cases in the union set of A and B. The logical values indicate whether the union set of A and B is present in a given case, value 1, or not, value 0. For the test of necessity, we would like to figure out if a condition is also present in all cases where the outcome is present. For the union set of A and B, whenever the outcome is present, value 1, this condition is also present, value 1. We see enough empirical evidence to confirm the necessity claim of the union set of A and B for the outcome high performance firms. We can conclude that firm investing in AI or firm investing in people is the necessary condition for high performance. In conclusion, we have the logic of necessity for QCA. Whenever the outcome is present, the condition is also present, and that condition is necessary for the outcome. No cases should be displayed when the outcome is present but the condition is absent. and in the representation form Venn diagram. X is the superset of the outcome Y. I hope you have enjoyed the course. There are more relevant topics in this course. Let's learn more and see how you can apply set theoretic methods like QCA in your profession and social science research. Thank you.